confidence interval, if you do a confidence interval, it's sufficient enough. And if you do a hypothesis test, among the different hypothesis tests you're going to see, it's also sufficient. So you don't have to do both of them. That's number one. Number two is that there's nothing called a hypothesis test or significance test. You normally have to go ahead and define what you're doing. Either you're doing a t-test, or you're doing a z-test, or you're doing the other tests such as the chi-square test, ANOVA test. And when you do a t-test, you're doing a t-test for a mean. And you're doing a t-test, you can do a t-test for a proportion. When you do a t-test, you can do a t-test for two means and two proportions. So hypothesis test is just the general name that you can give it. Number three is that to calculate a confidence interval or significance test, you must have, you need to calculate something known as the standard error, which differs according to the calculations you're doing. That is, if you're doing for one mean, or you're doing for a proportion, or you're doing for two means or two proportions. So before you calculate any of these tests, you need to have an idea on how you're going to calculate a standard error for these different situations. I hope that makes sense. So that's a must know for these 3 points. Now, these are examples of the significance tests that one can use. Okay, you can use a t value, you can use a z value, you can use an f value, you can use a chi-square value. Okay, but importantly, I want you to understand how you're able to formulate this hypothesis. Is the really important thing. Okay, so for example, I mean, all of them are the same except for the chi-square test. So for you doing a t value, so it's either you're doing a t value or z value. Normally, the null hypothesis is that you're stating that the means are equal, i.e. there is no difference between the values or the means that you're doing or the proportions you're doing. And then if you're doing an alternative, your alternative hypothesis will mean that they are going not to be equal. Okay. The z value is the same. You're saying the two means are equal, or the two means are not equal. So I want you to know, like when you're writing, when you're told in a question, formulate the hypothesis and calculate the significance test. So you need to know how to write that my null value. If you write null value, the means of two groups are not equal. That's not a correct null value. I mean null hypothesis. You need to write that the null means there's no difference, there's equal. And in an alternative means that they're not equal. Okay. So it's the same for these two. These are the ones, and it's rare for you to be given a question on them, but when I give you the slides, you might go over them as well. So these are significance tests. I don't want to confuse you guys. We said you're either told to calculate a confidence interval or hypothesis test. And for hypothesis test, also called significance test, you can have all these tests: a t value, z value, a t test, a z test, ANOVA, and a chi-square test, isn't it? So I want you, or a Fisher test. All those ones are significance tests. Now, in this slide, I'll give you the slides, but I just want you to take the important thing. These are the important things that you have to know when you're going to the exam. And we say the most important thing is, right, knowing how to calculate your standard error. So if it's a single mean, the standard error is going to be given as your standard deviation divided by the square root of n, which is the number of values or number of items you're going to have. Okay, so this is the formula. Your standard deviation, which you're going to be given in the question, and your n value at the mean. The next thing you must know is the difference. So if you have two means and you want to talk about the difference between two means, what you do is that you're having the one for one mean, which is this one you've discussed, and then you add it to the other one for the other mean, which can be given as, remember, This equation normally is actually your variance over the n, then you have a large square root. But since you know that the square root of a variance is a standard deviation, then you can write standard deviation over the square root of n. That's the only thing that remains at the bottom is the square root, I mean at the bottom. However, if you look at this other one, if you look at when you're talking about two means, this is the value that I want you to remember, that you're going to talk about the variance over n plus the variance over n, so n1, n2, and then you have a large square root of all of them. Or you can just remember this one and do this one, and then you add for the other one. Yeah, the point is you're having an addition here. So that's for two means. For proportion, this is the value, the square root of PQ, where Q is 1 minus P over N, right? And then the difference is just taking this one and then adding to the other one. So you have two proportions. You're taking one proportion and adding it to the other. Yeah. So I'll give you this slide, and you guys have your own slides in from Biostats. You can go through and see the difference, the difference in the standard errors for all of this, right? Importantly, I want you to, okay, we'll see that in the question. Now, the other thing you want to do is your interpretation. At the point of interpretation, you can either, so we have stated your null hypothesis, and you either want to accept it or reject it. And when you reject your null hypothesis, you you agree or accept your alternative hypothesis. So what will you do when you're rejecting a null hypothesis? You reject your null hypothesis if the following is there. So in a Z value, if your Z value you've calculated is more than 1.96, which is 95% confidence interval, you reject your null hypothesis. The next thing is if your p-value from your Z calculation is less than 0.05, you reject your null hypothesis. So your p-value is calculated using a table. So since you're not going to have the table, you just use the Z value. But if you have a table, you can also go ahead and calculate the p-value. And then if it's less than 0.05, that's when you're neglecting or you're rejecting a null hypothesis. The rest, generally in confidence interval, you don't have a null hypothesis like you to state it, but you reject the concept that those two are equal if the following happens. Either the mean difference, when you calculate a confidence interval, you're going to have two values. So if the two values when you're talking about two means does not include zero, so it's above zero, does not include it, you're going to reject it. You're also going to reject it if the odds ratio or the relative ratio is going to be or risk ratio it does not include one. Okay, and then the last one is the confidence interval between two groups do not overlap. So you're comparing two means, and when you calculate the confidence interval for one mean, you just look at the other and say, is it inclusive within the confidence interval of the one of the mean you've calculated? If it's not part of it, then you're going to reject. So these are the 5 things you're going to reject the null hypothesis, which states that the two mean or the two proportions or the one mean and one proportion is going to be equal. Hence, you're going to accept your alternative hypothesis. Now, so these are the steps that you can use for your calculation. Number 1, you want to identify whether you're dealing with one mean or one proportion, two means or two proportion. So standard error, this will help you know which standard error you're using. And this one, you're not going to be told, you have to identify it for yourself whether or not you're dealing with one mean or one proportion or two means or two proportions. Yeah. So how are you able to identify it quickly? Is that if you want to know two mean and two proportions, you're going to have two different studies that was done. So you're going to be told that one study was carried out and this was the mean, and the other study was carried out, and this is the mean. So that means we're having two means. Or one study was done, these are the proportions, the other one, these are proportions. Those are two proportions. However, for one mean, you're going to have one study and then you're comparing it to the mean of the population. Or a proportion, you're going to have one proportion and you're comparing it to the proportion of the population. So at the end of it all, for all of these questions, you're going to have either you're going to have two means for all questions, but the other mean is what determines what you're dealing with. For example, the other mean, if it's a population mean or population proportion, you're dealing with only one mean. But if it was two studies that was carried out and you're dealing with two different studies, so you're going to have two means, two proportions. Hopefully that makes sense. The next step after you identify whether or not you're dealing with results, you want to formulate a hypothesis. As I stated, for confidence intervals, you don't have to, you're not required to formulate hypothesis. The other one, hypothesis test, is where you have a hypothesis, but you have it in your mind for confidence interval. At the end of it all, you just want to say, is it equal or not equal? And it's the same thing as the null hypothesis. Null hypothesis wants to identify whether or not it's equal or it's not equal, and then you can identify your hypothesis. The third thing is, according to your question, identify which test you will use. Either hypothesis test, which is Z or T test, or you're using your confidence interval. So most of the time you're going to be told, using an 85% confidence interval, calculate whether or not they are equal, or formulate your hypothesis and calculate whether or not they're equal. So you're going to be told for this one. The fourth thing is you're using your criteria stated before. Yeah, so what we talked about interpretation. So whether or not you want to accept it or reject it after you've calculated. Okay. Now we are there. So until there, I hope those are just basics. I want now us to take a sample question so that we can understand. And this one, I'd require everyone to be active. So if you're able to open your mic, open. If you're able to calculate it, have your calculator, because we need people to be active so that we can see whether or not I'm making sense. Okay. So in a health survey of children, of school children, it is found that the mean hemoglobin level of 55 boys is 10.2 milligrams per 100 ml, with a standard deviation of 2.1. Using a 95% confidence interval, can we consider this group as taken from the population with a mean of 11 milligrams per 100? Yeah, so that's the question we're being told. We're using the 95% confidence interval. So step one, we said identify whether or not you're dealing with one mean, one proportion, or two means of two proportion. Who can tell us, are we dealing with two means, two proportions, or one mean or one proportion from the question? Yes, we have one mean. Single mean, yes. I need to see more so that I'm seeing 130 people here. Let's see, show that we are moving together. One mean, yes. One mean, right. So most of us are agreeing that this is one mean. We said you're going to have always in your questions, you're going to have two means, but you need to know what is the second mean. One mean was that they did a study, and this study found this was one mean. And the other one is you're looking at the population. So we are not dealing with two studies. We're just dealing with one study, and the study is being compared to the population. So we're dealing with one mean. That's nice. The next thing is standard error to be determined. Yeah. So What are we going to use for our standard error? Because we have identified that this is one mean, we are going to use the standard error of one mean. Okay, so standard error of one mean is calculated as standard deviation divided by the square root of n. For someone to quickly calculate it for us, standard deviation from the sample question, what is the standard deviation, and then let's divide it by the number of n. 0.283. Yes, so we are getting it. So 0.283. That is your standard error of mean. So we've already put our standard error of mean aside. That's okay. The next step we said here was formulating a hypothesis. I know we are doing a confidence interval, but just for the practice of formulation of hypothesis, someone can tell us, can just tell us what would have been a null hypothesis if we're using a Z score, let's say. What would be the null hypothesis here? Someone can just tell us, shout it out, because it's a whole sentence. Anyone wants to try? Yeah, so the mean, yeah, so you can state it, yeah. So the null hypothesis would be the mean is equal to the mean of that of the population, yeah. So, but remember, we said we are not doing it here in confidence interval. Please don't make the mistake. We're just practicing here so that we're saying it. So the null hypothesis I would have stated is there's no difference between the sample and population mean. Or you would have said the mean, sample mean, and population mean are equal. And my alternative hypothesis is there is difference between the sample and population, or there is no, they are not equal. Yeah. Okay. So that was just a confidence interval. You are not doing that one. Okay. Step 3, I think we have already done it. We have already identified we're using a confidence interval. Now we can then use our calculation to be able to 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 make it. Okay. So when we're using the 95% confidence interval, this is the formula we want to use. That the confidence interval is equals to, this is the mean of the sample plus or minus 1.96 multiplied by the standard error of the mean. Okay. Standard error of the mean you've already calculated as 0.283. The mean, we already have it here in our question, was 10.5. So we are doing 10.2. 10.2 plus or minus, yeah, 10.2 plus or minus 1.96 multiplied by the standard error of mean. This will be it. So someone tell us quickly what would be the answer. Two values, 10.2 plus or minus 1.96 multiplied by the standard error of mean, which is 0.283 as per the calculations done. 10.8, 9.6, okay. 10.76, yes. As the upper value, what if you subtract it? 9.6 approximately, okay. 10.75, 9.64. 10.75, 9.64. All right. So that's great. Those are the two values you're going to have. Yeah, 10.76, you can round it off at least to 2 decimal points. So that's the confidence interval, the interval. Meaning, this is what we mean from the question here. We are saying that from the test or the study we did, we are 95% confident that the mean of the population from which these people as students were taken the mean would lie from 9.645 to 10.75. So I want someone to then use the fourth criteria, which was to interpret what are we interpreting from this value. Are they equal? Is this sample we are taking, is it from the population mean, or we are having a different population? Okay, so we have two. One says it's from the population mean, another one says it's from the different population. Let's hear from the rest. And maybe give us an explanation. iPhone 15 Pro Max. Tell us why it's from the same, and maybe Maureen can tell us why is it from different population. It's falling in the range. Different, that's another answer. Anyone else? Different population, 11, it's outside the range. Yes, 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 yes. So from what we have calculated, our range is from 9.6 to 10.75. And remember that this population mean is 11. So we say that, however, we were confident, 95% confident that this sample, the mean in which the population comes from is from 10.76, and I mean 9.64 to 10.75. So when you're having a different population, it's definitely a different number. So it does not fall within the range. Yes, so that's okay. There are different explanation used. So this one, we are using the fifth group, the confidence interval between the two. Now the mean from the population and the mean from the sample, they do not overlap. Means that one must be different from the other. They're not coming from the same thing. And from our question, it's that we were using the sample mean to get to 95% confident that this sample, the sample we've taken, the mean of the population is going to range from 9.6 to 10.75. Hence, an 11 mean of 11 is from another population. It's not from this population. So we have used one of these to be able to 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 remove this, isn't it? So number 5, I want you to remember number 5 about overlapping is going to be, it's really important because this one, number 3, is only used for confidence interval. It can only be used if you're dealing with two means and two proportions. And this one, as you can see already, it's used for the odds ratio and the risk ratio. So it doesn't apply here. But then for number 5 is when you're going to use it for most of the time, for one mean and one proportion, which most of your questions are going to be one mean and one proportion. Sasa. So that was that one. Okay. In case we decided to do the Z value, okay, I don't know if you have the time to be able to deal with the Z value here, but the Z value, uh, the calculation for the Z value would be, okay, I, I haven't written it and I can't, okay. So I'll leave that one for you guys to practice the Z value from this population, okay, and see if you're getting the interpretation at the end of it all, that both of them are not equal and they're not from the same population. So I'll give you another sample. So before we go on, is there maybe a question before we leave? Anything you want to clarify? Okay, so I guess you're okay. So I guess you're following. Okay. So this is question 2. Suppose we're interested in studying the proportion of children living near a lead smelter who have colic. Yeah. The prevalence of colic in the general public is estimated to be as low as 7%. Yeah. So that's one. If from the sample, 124 children were taken, okay, 23 of them have colic. Test at 5% significance whether the prevalence of colic among children who live near a lead smelter differs from that of the general public. State your hypothesis and your conclusion. Yeah, okay. So we go to step one. Step one was we want to identify whether or not we're dealing with one sample, one mean, one proportion, two means, and two proportions. So let me go back to the question. Someone to tell us, are we dealing with one mean or one proportion or one two means and two proportions? So we're getting one proportion, two proportions, one proportion, two proportions. All right. So we said that if you want to know whether or not you're having two proportions in two means, yeah, and you're always going to have two samples. You're always, I told you always in your question, you're going to have two means and you're going to have two proportions. But to identify whether or not you're dealing with only one proportion and one mean and one proportion, how you're going to identify it is one was gotten from a test, from a study that was done. That one you're going to identify and say this is proportion one. If there is another study done, then that will be proportion two. So if you only have one study done and you're comparing this study to a general population, to the population mean or to the population proportion, yeah, then you're dealing with one. But if you have two studies, you're told sample 124 samples were taken and this one was gotten, and that one, these samples are taken and this one were gotten, you're dealing with two proportions or two means. Okay, so from this one, we only have one sample. Yeah, you're told a sample was taken of 124, 23 or were tested. Okay, but we have a general public. So general public is the population. We're estimating it that they have a proportion law as 7%. So that means we're dealing with only one proportion. That was nice. At least we identified. We didn't. No one said one mean or one meaning. We're seeing this clearly the proportion. So proportion is a value of another value. Okay, so that was good. We have identified one proportion. So from one proportion, we use our standard. Immediately identify whatever you're dealing with, calculate a standard error. That will be the easiest thing. Okay, so we calculate our standard error. And our standard error, yeah, is P minus, P into 1 minus P over N. Okay? Now, here is where the catch is that when you're dealing with a proportion and you want to, okay, before we go there, let's go to step 3. I'll come back to this. Step 3, are we dealing with a confidence interval or are we dealing with a hypothesis test or significance test? Hypothesis. Okay, hypothesis test. Yeah, awesome. So for hypothesis test, and when your sample is a large number of sample, you normally use the Z test. Okay, so here we are dealing with the Z test. Those on step 3, we're able to have that we already know that this is a hypothesis test. Okay, so the catch is, and this is only, and that's why I use this question, it's only used for this specific, for a proportion, and you're dealing with a Z test. if you're dealing with a z-test and you're dealing with a proportion, yeah, what you want to do is that when you're calculating this standard error of proportion, it's the standard error of proportion of the population and not the sample. So instead of getting the standard error, the standard error of this of this sample, we're using the proportion. This is when you're calculating your z-test. Only your z-test for one proportion, you're going to use the standard error of population. That's a very clear exception. So you're using this value. So what's my proportion? 7%. That is 0.07 into 1 minus p, that is 1 minus 0.07, and then divided by the total number of people who are in this test, which was 124. Who can give us the answer? 0.0229. Any other? Okay, so 0.0029, right? So that is your standard error of proportion. Step 2, you've already identified and you say that this is a hypothesis test. So who can write for us the hypothesis? Someone to test for us a hypothesis. Someone to tell us, write for us a null hypothesis and the other one, alternative hypothesis. Anyone? Yeah. So it's as easy as that. That there is no difference between the sample and population proportions, and the other one is this difference between the sample and population proportions. So those are the NINI. Remember what we want to know is that whether the prevalence of colic among children who live the lead differs from that of the general public. So we just want to know whether or not the proportions are equal from the general public and the proportions of the, the test that we do or the sample that we've used. Okay, so those are the hypotheses we do. Now, after that, we then go to the calculation. So this is the calculation that you're going to do. So from the sample, subtract from the proportion of the sample of the proportion of the population, and then you divide it over the standard error of the population, not of the sample, of the population. So this is going to be the values. Anyone can calculate for us? Okay, so 5.04. 5.04, you then go to interpret it. So this is Z value. So we go back and see the interpretation where we have used a Z value. Yeah. For a Z test, you can either calculate it using two things. You'll see Z value, it's either more than 1.96. Yeah. So this is when you're using a 95%, yeah, or 5%. Then p-value is from the Z calculation is going to be less than 0.05. So in exam, you're not going to have the tables. So you're not going to calculate the p-value, yeah? So you're going to use the Z value. So anything more than 1.96, that means that you're going to have your to reject your hypothesis, yeah? So there is the interpretation. You say that 5.04 is greater than 1.96. Hence, you reject the null hypothesis and accept the alternative hypothesis. Yeah. So that is when you're using the Z test. Yeah. Higher. We said we'll come back to this question. Just quickly, when you're doing the Z test for this one, I can see someone has already given us the answer for the Z test for. Yeah. So when you're doing the Z test, what are you going to take? The Z test is going to take the mean, yeah, and you subtract it from this other mean, and then you divide it by the standard error of mean, which was a 0.02, if I'm not wrong. That is going to be the Z test. Now from the calculation, the Z test that was done here, you're going to have 2.825. Someone to interpret for us whether or not the first example with a Z test of 2.85. That means it's more than 1.96. That means you're rejecting the null hypothesis that these two people, the sample and population are equal or from the same, they have the same value. So we reject it and say they are not equal, and hence the sample is from a different population. Now, we can try use the standard, the confidence interval for this other test. Yeah, it's the same thing that we did here for here. So we'll just take X, which is the value, the proportion here. Yeah, and the proportion here is going to be 23 over 124 into standard error. So you'll use that proportion, then plus or minus. Yeah, someone can help us with that one. Someone can help us with that one. I'm going to answer the questions. Just give me a minute to do this one. So someone can help us with that one. So we do the proportion 23 over 124 plus or minus 1.96 and multiplied by the standard error. But this time, the standard error, we are not using the standard error of the population. Rather, we're using the standard error of the sample. So we'll use the standard error of the sample, which will take this proportion into 1 minus this proportion and then divided by 125. Whatever you're going to get two values. Why are we doing that one? The essence is when you're getting two values, we're using a sample and you're saying that you are 95% sure that the true population proportion will lie between these two. So the standard error we'll be using there, the standard error of the sample. We're saying that this is from the true population. Yeah. So don't be keen on that one. If you're doing a confidence interval, you'll be using for the sample and not the proportion. 11.6 to 25.4. Yeah. And if you do that one, you clearly see that 7 is not ranging between the two proportions. And hence you can say easily that they are not equal, isn't it? And this is from a different population. Okay. So I can quickly go over the charts. The standard error you divided it is 8 of the sample or the proportion. So we said when you're dealing with a Z test, you're using for the population, not proportion, for the population. And then when you're doing the confidence interval for the proportion, you're going to do using the sample. Okay? Hope that makes clear. If it's the Z test, you're using that one, and then if it's the other one, you're using if the Z test used for the standard error of population. If it's the what is it called, confidence interval, you're using for the sample. Or do we get the standard error? Yeah, I think I said that one. Don't we use the square root of the standard error? No, so from the standard error, when you've already calculated the standard error, it has already removed the square root. So remember when you're saying somewhere like here, so this is the standard error. So when I say the standard error, I've already done the square root here. So I've said S divided by the square root. So you're not using any other square root from that one. Please recap this second question from step 1. Okay, I'm getting different. So we've agreed with one proportion. Yeah. So from the proportion, you want to identify whether or not we're getting the standard error. So I've said if you're doing the Z test, you're using the proportion standard error. So when you're using these values, you're using the values of the P of the population. But when you're doing when you're doing the confidence interval, when you're getting the standard error, it will not be it will be of a population, not of the sample, not the population. So the standard error here would be P1 minus P, and hence it will be 0.18 into 1 minus 0.18, and then divided by 125. That will be in the confidence interval. But then if you're using the Z test, you're going to use it this way. In case of, this is only for the proportion. You don't use it when you're using the mean or anything like that. Where is the 0.18 coming from? It's coming from here. So this is the proportion. If you do 23 divided by 24, that will be the proportion of the sample. So that's the proportion. So 7 is the proportion of 7%. So 0.07 is the proportion of the general population. And then the proportion of the sample is 23 divided by 24, which is 0.18. Yeah, 124, yeah, not 125, 124. Can we repeat how to get the standard error for confidence interval? I think I've seen repeat the standard error of the proportion. Could you repeat how you get the standard error? And confidence interval, standard error of mean. No, so when you're using confidence interval in the it's not haichanganishi. Why? Because confidence interval of a mean, it's only the standard deviation divided by the number. So standard deviation, there's no standard deviation of the mean or the mean. It's only you'll be given one standard deviation. So you don't have this confusion of are you using proportion of the mean or the proportion of the mean. I hope that makes sense. Like when you're using the standard error of the mean, the formula is standard deviation divided by the square root of n. So there's you're not using the mean of the population or the mean of the sample. You're not using that. But now here, why we are doing that one is that we have two proportions, and the formula has to have one of the proportions. So the confidence interval, you need to say that this is the sample I used. So I'm 95% confident that this is the nini that you're using there. So yes. Okay. we've said, just take it as a general rule that if you're using proportion, use one proportion. Yeah, one proportion and you have the population. So proportion of the sample and you have the proportion of the proportion of the sample and proportion of um the proportion of the sample and you have the proportion of the population. Yeah, 0.18 is the proportion of the mean. So we're dealing with a proportion here. So proportion of the sample, proportion of the population. Yeah. So when you're doing your confidence interval, as a rule, you're using the proportion of the what is it called? Confidence interval, you're using the proportion of the sample. But when you're using the z-test, you're using proportion of the population. I hope that makes sense. So the only difference is calculating standard deviation, I mean the standard error. And it won't apply in any other thing, either in two samples or in two mean or two proportions or one mean. It won't apply in any of these things. It only applies in one proportion and you're having a population proportion. So for that type of a question, if you're told to calculate confidence interval, you're using the proportion of the sample. If you're told to calculate the proportion of the z-test, you're using the standard error, you're using the proportion of the population. I hope now it makes sense. No, it's not. So when you're dealing with a mean, one mean or two means or two proportions, you just know it will come automatically. So if you're dealing with one mean, you're only going to be given one standard deviation. And the formula is standard deviation over the square root of n. So you're not going to have any other problem when you're dealing with that one. It's the standard deviation in the mean. Yes. So this the standard deviation in the mean in the sample. You're only given one. So there's no confusion there. It's only one. But here the problem is you're having two proportions. So the one proportion will be used in z-test, the other proportion is used in confidence interval. So when should you use 124? No, it's 23 divided by 24 as a percentage. So we're using the decimals to make it easy. So if you're using percentage, see, 23 divided by 24, you're getting a decimal 0.18. And then 7% is 7 divided by 100, that's 0.07 decimal point. Yes, we had a choice of using. So the question is, so for the first question, we also had a choice of using the z-test. Yes, we had, and that's what we did calculate it. I think Khulud is the one who showed us. So you can use the z-test and calculate it and then in it. But it differs on what the question tells you. So you see this one, you're being told, state your hypothesis and conclusion. That means they want a hypothesis test. And this other question, they were telling us using 95% confidence interval. So they have restricted us to use a confidence interval. The other question has restricted us to use a hypothesis test. So it's not in a case where it's open, you can do both. Yeah, I mean, you can choose any, but most of the time they'll specify, they'll tell you using a confidence interval or using a hypothesis test. Or you're told formulate a hypothesis. Then you'll have to formulate it and then you use one of the Z test. Mostly it's going to be Z test because this test is when you're using small number of values. So I hope Sija will confuse me more. So these are the two sample questions that I wanted to show you. At least I've covered how a z-test is calculated, how a confidence interval is calculated, and how you can use and you can be able to interpret both of them. You've done the most common at your fourth year, which is going to be for one proportion and one mean. That's the most common thing you're going to be asked for fourth year. Yeah, so I think I can end it if there is no another question. Yeah. Yeah, all the best in your exams.
Okay, thank you very much, Adnan, for the session. Shukran. We'll close with a dua. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت نستغفرك ونتوب إليك. Thank you very much, everyone, for attending, and good luck in your exams.
Yes, you're all welcome. Thank you.